הצטרפתם אלינו ערב למפגש הרביעי של Israel Robotics Meetup. אנחנו קיימים אנחנו קיימים קצת פחות משנה, אנחנו כבר קהילה של למעלה מ-1,000 איש. לפני שאציג את המרצה הראשון, אני רוצה להגיד כמה מילים על המיטאפ והצוות המארגן שעומל ימים ולילות בהתנדבות מלאה. עמית, שהולך לדבר את ההרצאות האלה, דורון, אריאל מאחורה, שאתם מכירים את מהקבוצת פייסבוק, ארבעתנו באים מרקעים שונים, ולא הכרנו לפני שעבדנו ביחד על המיזם הזה. מה שמאחד אותנו, גם אמרתי במיטאפ הקודם, זה הרצון להיות ישראל מובילה לתחום הרובוטיקה בעולם, הקמת סטארט-אפים פורצי דרך, עידוד השתתפות אנשים בכל המגזרים, עידוד חשיבה מקורית וריכוז טאלנט ברמה בינלאומית כאן בישראל. ברמה הפרקטית, רצינו לדבר על שני דברים. אחד, אנחנו מחפשים ספונסרים שיתמכו במיטאפ. עד היום כל הוצאה יוצאת לנו לכיס, אז אם זה רלוונטי לכם או לארגונים שאתם מייצגים, תנו אלינו. הדבר השני, אנחנו עובדים על סוג של דאטאבייס פתוח, ספרדשיט של גוגל, עם פרטים של חברות ואנשים שמתעסקים ברובוטיקה בארץ. אנחנו רוצים לדעת מה דעתכם על זה, אם יש צורך בדבר כזה, אם אתם רוצים להיות קונטריביוטור בדבר כזה. אולי יש כאן מישהו אפילו שרוצה לנהל את הפרויקט הזה ולקחת אחריות עליו, אז תנו אלינו אם זה מעניין. אז מה עוד? תודות למרצים הנהדרים שעשו איתנו הערב דיפ דייב טכני. זה הטים של היום. דיוויד קלר ידבר על מגמות בעיצוב מערכות רובוטיקה. עמית מורן וגיא לוי ידברו על תכנות וסימולציה ברוס. אפי ויצרבן, CTO של תמי, על השלבים הכרוכים בתכנון ויישום של מערכות רובוטיקה משוכללות המיועדות לאינטראקציה עם אנשים ביום-יום. מי שלא מכיר את תמי, מרתק. לבסוף, להודות לכם, הקהילה, תהנו, תתעניינו, צרו קשר ותצליחו. המדיניות שלנו לגבי שפות היא שכל מרצה יעשה את מה שנוח לו. אני אעבור לאנגלית עכשיו, להציג את עמית מורן. So, Amit Moran is the VP R&D and co-founder of Indoor Robotics. Previously, for a short period, he was the VP Innovation of TEMI, which we're going to hear about tonight. He was in charge of internal POCs on creating the developers' tools and experience. Before that, Amit was about 7 years at Intel Perceptual Computing Department, where he developed and led several novel projects in AR, VR, and robotics. That's awesome. In his last 3 years at Intel, Amit acted as R&D Robotics Innovation Team Leader. He and his team were researching, prototyping, and developing depth and perception capabilities for autonomous machines. Over to you.
Thank you. It's strange this time to be on the presentation side. Hope you'll bear with me.
So I want to get the lights.
Right. So I will do it in English. Let me know if you don't hear me for some reason. I'm a software engineer. I actually didn't think I would get ever to robotics before. Electronics wasn't my thing. And I got to love robotics about 4 years ago when I started to work on it at Intel because of the multidisciplinary nature of it. Today I'm going to talk about ROS, the Robotic Operating System, or basically how a software engineer can do robotics. How we don't need to know anything about electronics and actually do some cool stuff. I work for Indoor Robotics. I work and I also co-founded it with Doron. We are doing robotics for the indoor space, autonomous machines. It's kind of a stealth mode right now. We do look for a really good full stack engineer. If you know Node.js and you're interested in robotics and you feel like joining us, let us know. And now we go to the ROS. So I'm going to talk about what is ROS, some fundamentals about it, and I'm actually going to control this robot and compile code in real time here on stage. Stay tuned. There is a video here. I'm not connected to the internet, so I'm not going to show it. I didn't manage to embed it to the presentation. I'm sorry about that, but it's just 10 years summary in 1 minute about ROS. Interesting. I'll share it in the Meetup group. You can actually go and take a look all kind of robots using ROS. There are loads. This is just, I think it's the second distribution. This is every distribution of ROS has an icon or a graphic. And this is the second distribution. It's called Sea Turtle. They have something with turtles there. It's really cool because it kind of shows all kind of robots, and all of them are using ROS. If it's flying robots or sea robots, cars, autonomous cars, and personal robotics, and everything is using ROS today. Even the big companies using ROS, at least for the development part. Maybe for the product they use something else, but for the development, ROS is basically the standard. So, what is ROS? ROS started at the Stanford Artificial Intelligence Department in 2007. It was, as much as I know, it's a joint venture with Villa Garage. Villa Garage was a kind of an incubator for different, for personal robotics research, and mainly research. Since then, I think 2014, it has been stopped. How do you say that? Like no more company. Ceased to exist. Yeah. But a lot of other companies. Oh, you don't really see good. Huh? A lot of I try to just fix the resolution. A lot of other companies went out of it. For example, Open Source Robotic Foundation, which is maintaining ROS. ClearPath Robotics. I won't be able to do it this way. ClearPath Robotics, it's another one. Fetch and many other ones went out of this great incubator. I'm coming back. All right. So what it is? It's basically a set of it's communication framework in a way. Have process management, interprocess communication, abstraction for hardware, for cameras, for robots. It's something very important when you are trying to develop robots. It's a set of tools, interesting tool like simulation. The guy today will talk about it later. Visualization, logging, and etc. A lot of capabilities, libraries for mapping and navigation, etc. And a lot of them is open source. And I'll talk about it. The last thing is ecosystem. The ecosystem is very important. Much of the ROS ecosystem is open source. ROS itself is open source, and many of the libraries themselves are open source. And most of them are very permissive licenses, not all of them. So it's very interesting. Actually, I'll go on each of one of them, explain a bit. But as a software engineer, one of the first things you want to do when you start to work with a new library is to understand what is the support for this library, especially if it's an open source. How many people are using it, and if I have a problem, we'll be able to find a solution for it. And ROS is actually, as I said, it's basically the standard. People all over the world using it. There is a map here. There is actually a white dot here in Israel. It's cognitive. I checked. I don't know how they got there.
We have a
You have a package. This is why. Yeah, you have a package in ROS. So it's color coded in what is a school, what is a company, etc. It's nice. There is a wiki of about 20,000, a bit less than 20,000 packages there or entries. There is a forum and questions and answer, and you get all the time answers, and people are very active. So it's an awesome user base to be part of. Second thing is the capability I talked about before. And this is some of them which are interesting when you started to work on robotics. MoveIt is a library and algorithms to usually to move arms as much as I used it, although it's supposed to have some support also for mobile robot. It might have. I'm not 100% sure about that, but it's very, very advanced. Have all kinds of libraries for perception. There is native support for OpenCV and PCL. So OpenCV, for those who do not know, it's basically computer vision libraries, open source, that every computer vision engineer knows how to use. PCL is point cloud library for 3D processing. Mapping. When you have a mobile robot, you need to map the environment, understand where you can go and where you cannot. Outside there was a robot patrolling just before, of Mir, the robot was Mir, the company was Mir. Where is Meir? Meir will tell me if I'm right. Is it Mir or
MIR?
MIR, all right. So you might saw the laptop on it with the map and what the robot actually saw. Okay. And planning. You need to plan a path from one place to another. So, and this and many, many other libraries are available there. Most of them open source and BSD licensed, the ones for those of you who are interested. Some of them are GPL. There are some proprietary as well. There is no problem to create your own library, put it as a proprietary code, and use ROS. ROS itself is BSD, so it's very interesting. Tools. So again, very interesting if you are a software developer and you want to understand what you have in your tool set. So one of them is RViz, the visualization tool, to be able to see what the robot sees. There's a camera feed over there. So you see what the robot sees and the map and all kinds of other plugins, so it's just an awesome tool. RQT is graphical user interface for all kinds of other stuff. It's kind of a meta dashboard you can create out of it for the console to understand what's going on, to even see the camera feed, etc. So there's a, let's say it's not the best user experience, but it works and it's very useful. There was a graph. I'll talk about the nodes and how it works afterwards. But the fact that you can actually visualize things, it's very interesting. And here you can see not a very complex robot. So there is a lot of stuff going on in a robot. How different processes are communicating and how the connection between them. And you get it out of the box. Here it's Gazebo. Guy will talk about it afterwards. It's a simulation in ROS. It's not. I think it's not only for us, but it has a great integration for us. So it's simulating a 3D world. And in the right side here, you see the RViz part. You see what the robot actually sees of the world. So you can be at home, develop your algorithms, and simulate a very complex world. All right. So now we go a bit about the philosophy and the actual concepts behind it. So I think one of the most important things here is the hardware abstraction and standardization. Different programs communicate through defined API, through messages. So just for example, if you are using a camera, can you hear me good like that? It's good? Yeah, I don't need to bend every time. Yeah, so if you, for example, you connect a camera, you would like this camera to feed information to your algorithm, and the camera driver will output standard messages of images. So if you switch to another camera, a different manufacturer or a different kind, the same API changes. You don't have to do any changes in your code. And it's very interesting. Just for example, when I was back at Intel, and we developed a 3D camera. The processor computing department was about 3D cameras and perception, understanding of the environment for machines. And we developed several cameras. Another thing, the first thing that I did there was creating a driver. One of the first things I did for the robotics part was creating a driver for us. And it was basically outputting the data in a standard manner. And once it worked, there was all those algorithms that previously worked with Kinect, just worked out of the box for the Intel camera. Or almost out of the box, you just need to do small tweaks with field of views and distances. And this was just awesome. And if you're developing a new algorithm, when you camera, you use these standards, you're golden. Distributed, you can use different computers. We're going to show it here today in order to be able to be wireless. So everything is connected through networks. Multilingual, it has native support for C++, Python. This is, I think, the two main ones. You can still use Java. There is a version for Android. We actually wrote a driver for the Android application that connects through us and it does stuff. And there is JavaScript as well support, so it's very interesting. It's lightweight, usually how it's supposed to be. You're supposed to write your code and then just wrap it around a ROS layer. But all the code usually is in the library by itself. And free, I talked about this before. All right, so deep dive. Not that deep. The first thing you need to know, and you need to understand about ROS, and I'm talking about ROS 1.0, there is a new ROS 2.0 coming up. It's very different from an architecture point of view, but I'm talking one that most use. So the ROS master is basically kind of a DNS server. You run it on one time, there is one instance of that in your different machines, and this is where the ROS manages all the information, all the communication between the nodes. You start a new node, I'll talk about it in a second, you are connecting to the ROS master. You start a master with ROS core, and we're actually going to do it. Just want to make sure. There will be code here. Sorry. I'm good. Okay, so I'm basically just checking that my ROS master is on my local network. And I'm just starting the ROS core. And here we go. I have a ROS master running on my computer and waiting for nodes to register to it. The second concept is a ROS node. A ROS node is basically an application. It's a single purpose, supposed to be an application. You're working on it individually, and when a ROS node launches, it automatically registers. Not automatically, you need to register your node to ROS master, and the ROS master basically enable you all the communication. If you want to run a node, those are the commands I will share. By the way, I took some of my presentation here from a different presentation. It's in the end, the resources. I just found it very useful. So for example, if you want to run some kind of a code, you do ROS run, and what was that? Let's do something else. You know what? Let's do ROS topic echo. Let's ROS topic pod. Let's say Israel Robotics Meetup. It's a new topic. I will talk about it in a second. I'll show you how it works. And standard messages, string. Everything has a command line interface here, and I will say hey. So basically now I basically created, without writing any code, I created the new node that publishes a string of data with the data A, hey, let's say. I can create another node that listens to this information. Hey, see it here. So now every time I'm going to change and say, hey, everyone, hey, everyone. It's that simple. And if I want to see which nodes are running, I can do ROS node list. And I have a ROS out. This is basically the logging. And I have two topics here, which are nodes we just created on the different terminals here. And I can actually create more to do ROS topic info to see what is this topic IRM, and it tells me, hey, this is a topic of type string. It has publisher and subscriber, and very easily I can start to understand what's going on with my system. Right. And now we saw a bit what it means, the topics. We saw it now together with the nodes. The topic is basically a pub-sub mechanism. All right. Thank you. It was fast. So I'll go quickly here. Topics are a pop-up mechanism. You can create a topic by saying this is the topic I'm supporting, and this is the type of topic, and a lot of other nodes can subscribe to it and get information. It's actually an end-to-end, but typically it's a one-to-many. You can theoretically and practically publish the same topic and different messages, but usually it's not working this way. There is also services, which is basically an RPC, remote procedure call, and then it's one-to-one. It's very useful when you want to ask a question and to get an answer back. All the information is basically in the form of messages. We said before, you can define it in your own package, in your own project. In this manner, you say I want an integer, a double, a string, you write it this way, and you can create a new message type, it can be nested, and create a more elaborated code. Resources are here, I'll share everything. I have a bit more time, so I'll try to show something here. It's a bit big. But what you see here is visual code. There is also a plugin for ROS, which is awesome. And this is a node of ROS node. Basically, it's a main. I'm registering to ROS here, giving it a name, advertising a topic of a twist manner, twist type. So once I will run it, people will be able to register to this topic, and the name of the topic is this long name. There is a reason why. And here I'm starting a loop. I'm giving here a rate, 30 hertz. So this is the rate. And here I'm going to do something. So since we don't have much time, and unfortunately I did thought about preparing it ahead. And then there's good. This is very simple code. Right here, and just all right. So basically, I'm taking a counter, making sure that I have 2 seconds. Rate is the number of minutes and number of seconds I have. So 2 seconds. I'm giving it a linear speed of 0.15 meters per second, and publishing it. And after that, once I'm passing the 2 seconds, I'm actually rotating it and giving it an angular velocity. And I'm going actually to move this robot here next to me. It's connected. Yeah, I'm basically just changing that. Have much more time or not? How much more time I have?
49 seconds.
Awesome! So what I will do, and now it doesn't connect me also to the... Since I don't have much time and the connection doesn't allow it for some reason, I will take questions. Yeah.
So do companies like Waymo, Google, the autonomous car division, and Boston Dynamics, do they use ROS to for their Waymo for their cars, and Boston Dynamics for their robots, like for example Big Dog and other?
I don't know. I know. I'm pretty sure that Google is, but I don't know. I know another. Startup, TikTok, it used to be that there was a guy there, Ryan, who went out of the cloud robotics of Google. They put a lot of effort in ROS, so I'm absolutely sure. The first Android version of ROS was from the Google team. I'm pretty sure they're using it. I know another bigger company, I think it's Bosch, using it for the research. And afterwards, for the product, they probably won't use it, but for the research, they absolutely do.
What, humanoids too?
The humanoid?
Yeah, the robot that made humanoid robotic system.
I don't know. I don't know.
Actually, Boston Dynamics, they published, Google it, they published raw simulation for Apple. So for sure they use ROS. No internal info, so we don't know for what.
So ROS is becoming a standard?
ROS is the de facto standard.
Yeah.
Yeah, definitely.
What is the competition of the standard or?
There used to be one from Microsoft called Player, but it's not more anymore supported. There is some proprietary, there is mostly proprietary frameworks that are don't have as much success. There is another one, I forgot the name right now. You can go to the ROS website, you get also the other possibilities. But since ROS is free, all the universities are using it, and lately, it was main universities, I think it's still main universities are doing robotics, like seriously. And so because of that, it just spread it pretty good. And also the DARPA challenge, they adopted ROS. There is a DARPA challenge like for robotics, and they adopted ROS a few years ago, and since they adopted it, it made a big jump, and since then it's just everyone is doing it.
So in the visual studio class, when you do real-time debugs,
you can do, the nodes. You can do breakpoints, right? Is what you meant?
Yeah.
Yeah. You can put breakpoints, and it's an application. So it's an application with some dependencies on the end.
So was many versions historically of the ROS, is it compatible? The nodes? Is there a process to migrate?
So you have distributions of ROS. Every year there is a value distribution. Every 2 years you have an LTS, long-term support distribution. It's basically better to stick to a specific distribution. The OSRFs maintain it, and they make sure it's okay. And if you want to move to another distribution, you might need to do some adaptations. So it really depends on you. Usually distribution link is linked to Ubuntu distribution, which is LTS as well.
So if there's a project and they go, for example, I want to do a new version, is it possible?
It's possible. You just need to do some. You might need to do some adaptations in your code. Depends on the library you use.
That's for
Huh?
That's called Mindstorm.
Mindstorm. And Lego Mindstorm. I don't know. You might. I actually used Mindstorm with ROS, but we did some through Android. We did some adaptation. There was someone there, yeah.
You mentioned before that you would use ROS for development.
Yeah.
Would you consider it for production as well, or?
So some robots do, like the Saviok. Saviok, they're doing a hotel butler robot. They're using it. Fetch Robotics are using it. There are a lot of companies are using it for their production work. You can. There's some security issues there. You need to make sure that it's not secure. So you need to make sure you are fine with that, or you need to basically develop your security on top. So you can. You just need to. It really depends if you need. It takes a lot of memory by itself and a lot of space. So you need to make sure that. If you have enough space, you can enough resources. You absolutely can. If you don't, you might want to do something later. Yeah.
Can ROS work with neural networks?
So you can. There are packages that have support. So again, as I said, ROS by itself is a communication framework between different processes. So you can create your library for neural network. There are some specific companies that are doing AI for robotics for ROS, and they're doing these kind of things. There is no problem. So yes, it's just ROS by itself is not. It doesn't give you this capability. You have some libraries for it. Yeah.
Can you explain a little bit about the build of materials of these robots?
Yeah.
The interfaces.
Yeah, unfortunately, I couldn't show it live, but this one, so one of the things good about ROS is there is some out-of-the-box robots that just work with it. This is one of them, it's Turtleback 2. There is a 3 already, but it's a different one. I think this one is still used more. Sorry?
No, you say the name.
It's a Turtleback. So they have something with turtles. And it's basically kind of a Roomba base. The first Autobot one was actually iRobot base. This one is another company, it's called Kabuki. The company is Eugene. And it's basically kind of a vacuum cleaner, and it has like some stacks on it so you can basically put stuff. And it has a USB cable, which you just connect your laptop to your computer. And with ROS, you get the drivers for it. And with the abstraction, as I tried to show before, unfortunately I couldn't, but I don't know which robot I'm using. Here you can see, I'm just giving it a command velocity commands, like linear velocity or angular velocity, in this case. And any robot that supports ROS will know what to do with it. This one here, on the top here we have a small computer. It's not the case, but it's not the issue right now. It's a small computer that was supposed to connect to it and work with it. And you know, the demo guy didn't like me today. But eventually the base itself is like $350, and you need to add some batteries, and you get to $1,000 bomb for a very good research robot. And we are done. All right, thank you very much, guys.